Hi, I'm Dallin Riggs.
And I'm Zach Rhodes. We are seniors in the Department of Electrical Engineering at Utah State University. Together we formed a major part of the team that built the command and data handling system for the Biosentinel Cubesat mission.
Biosentinel is a NASA space mission sent to study the effect of solar radiation on organisms. Yeast is studied throughout 18 months in order to determine possible effects of prolonged solar radiation on humans outside of a low Earth orbit.
The command and data handling system is basically the brains of the satellite. It handles all of the communication between the different parts of the satellite, as well as processing the data and sending information back to Earth.
Two boards make up the command and data handling system. The first board is the single board computer, or SBC. This board houses the processor and the flight software and does the majority of the computation. It also stores the data gathered during the mission and relays it back to Earth.
The second board is the Integrated Expansion Card, or the IXC. This board is used to expand the communication abilities of the SBC. It houses an FPGA and basically acts as a telephone operator, relaying communication from the SBC to the different components of the satellite. This board also keeps an accurate record of the mission elapsed time to report how long the satellite has been in orbit.
The design process for these boards consisted of selecting parts for the mission that could be sent into space, followed by designing the schematics for the boards. After reviewing these schematics with more experienced engineers, the boards were sent out for manufacturing.
Once the boards were built, testing was done to make sure they worked according to the design and mission requirements. This included testing the software on the SBC and the firmware on the IXC, as well as verifying the power consumption on each board. Once the boards passed testing, they were shipped to NASA for inclusion in the satellite.
One of the challenges faced in the design of this project was getting the schematic design exactly right. This was critical to the overall project because if the schematics weren't correct, the boards would not work at all. Once the boards were built, they needed to be verified to make sure everything was built according to the design.
Another key challenge in the design process was the development of the firmware in VHDL. It was difficult to ensure that everything interfaced correctly and that the firmware could perform all of the functions in the requirements. It took a lot of care and time to finish everything properly.
We would like to thank the Department of Electrical and Computer Engineering at Utah State University for providing us with the skills needed to build such a project. We feel privileged to have been able to contribute to a successful NASA mission.